Hi everyone, in this video I'm going to go through the solutions for the FRQ number 6 from the 2016 exam. So for the setup here, we have two functions f and g. They've given us a table of select values for the function as well as their derivatives, and then they asked us a series of questions. This is largely going to focus on knowing your derivative rules. So in part A, they said let k of x equals f of g of x. Write an equation for the line tangent to the graph of k at x equals 3. So if I need to write an equation of the tangent line, I'm going to need two things. I'm going to need the point, and I'm going to need the slope of that tangent. So for the point, we're doing it at x equals 3, so I know that's my x coordinate. I need to figure out the y coordinate. So I'm going to use the definition of the function to find k of 3, and I know that's going to be equal to f of g of 3. So now I'm going to use the table. I know g of 3 is equal to 6. And then using the table again, f of 6 is 4. So I know my point is going to be 3, 4. So the next thing I need to find is the slope of the tangent. Now, I know I need the derivative for this. So the first thing I need to do is find k prime of x. Well, here I have a composition of functions. I have an outside function f and my inside function g, which means I'm going to need chain rule for this derivative. So chain rule says take the derivative of your outside function, which is f prime, leave the guts in the same, so it's going to say f prime of g of x, and then I'm going to multiply by the derivative of my inside function, so that's just going to be g prime of x. So now I can find k prime of 3, which is f prime of g of 3 times g prime of 3, and we can use the table. So g of 3, I believe we used that before, that was 6. G prime of 3 is 2. And now let's see, f prime of 6 gives me 5, so 5 times 2 equals 10. So the slope of my tangent is 10. So now that I've got the point and the slope, the equation of the tangent line is y minus 4 equals 10 times x minus 3. So for this one, in terms of points, they're actually, so this was all my work to find the slope, right? They give you 2 points for the slope, and then they gave 1 point for writing the whole equation. So it's 3 points for all of that work. All right, let's see, part B now. It says let h of x equals, let's see, let me write this down here. H of x equals g of x over f of x. And they want h prime of 1. So kind of like before we get h prime of 1, I need to write an expression for h prime of x. And we're going to do that using the quotient rule. So quotient rule, we know is low f of x, d high, so derivative of my numerator is g prime of x, minus high, d low is f prime of x, all over low squared. Oops, I'm sorry, you can't see that. Now, you can use your table. I know you can't see it on the screen here. So that's h prime of x. So now if I want h prime of, I think it was 1. Yep, h prime of 1, I'm going to use my table. So that's f of 1 times g prime of 1 minus g of 1 times f prime of 1 all over f of 1 squared. So f of 1 is negative 6, g prime of 1 is 8, minus g of 1 is 2, and f prime of 1 is 3, all over f of 1 is negative 6, and that's squared. So we're going to have negative 48 minus 6, all over negative 6 squared is 36. So I'm going to get negative 54 over 36. Now, here's somewhere where, especially for this year's exam, they have recommended just leaving these unsimplified. So I wouldn't necessarily worry about reducing this fraction if you're not sure that you can get it right. Now, we could easily use a calculator for that, and we would get -3/2. But again, given time, if you feel crunched, you can always leave your number, or excuse me, your answer like that, and that would be fine. Now, in this case, they're giving you 2 points here for this expression, not even evaluating it, but just can you set up what h of 1 is? And then they're giving you 1 point for the answer. Whoops, sorry. Okay, so 2 points for setup and then 1 point for the answer. All right, now part C is asking us to evaluate. So here we're kind of departing from derivatives a little bit and we're looking at an integral. And I'm going to show you this one 2 ways, just because I know some of you like U substitution and some of you don't prefer to use it if you don't have to. So if I'm going to evaluate this integral, the first thing I know that I need is an antiderivative. So I know the antiderivative of f double prime is going to be f prime of 2x. But what I also know is because of this chain here, the 2x inside, I would expect there to be a 2 outside because that's the derivative of 2x. Since there's not a 2 here, that means the original function had a 1/2. So for me, I know that this is the derivative, 1/2 times f prime of 2x plus c, and I'm going to evaluate that between 1 and 3. So then I've got 1/2 of f prime of 2 times 3 plus c, and then I'm subtracting 1/2 times f prime of 2 times 1 plus c. And so my c's cancel. I have 1/2 times f prime of 6 minus 1/2 times f prime of 2. Looking at my table, f prime of 6 is 5. So I have 5/2 minus f prime of 2 is a -2 over 2 from my 1/2. And so this is going to give me, that turns into a positive 7/2. So if you like it that way, you could be done there. Now, I know some of us are more comfortable with a U substitution. And again, this is an optional method. These are both valid ways of doing this. So let's say I looked at this, and I'm a person who prefers a U substitution. So I should recognize here my U is equal to 2x, which means my du dx is equal to 2, and dx equals du over 2. I also know I have to change my bounds. So u of 1, if I plug in 1 for x, gives me 2, and u of 3 gives me 6. So now this integral becomes the integral from 2 to 6 of f double prime of u times my dx was du over 2. So I get the integral from 2 to 6 of 1/2 f double prime of u du. So now I know my antiderivative. I have my 1/2. The antiderivative now of f double prime of u is just f prime of u plus c, and I'm evaluating from 2 to 6. So now I get 1/2 f prime of 6 plus c minus, 1/2 times f prime of 2 plus c. And you could see at this point, right, we're exactly where we were with the other problem. So this is going to still come out to the same answer, which is going to be 7/2. So again, it just depends on your level of comfort, whether you need to explicitly do the U substitution or you can manage it with the algebra here. So either way, they're giving 2 points for the antiderivative. So do you realize that it has to be the antiderivative of the second derivative is the first derivative, and do you have that constant out front? And then they're giving 1 point for the answer. All right, so that's 2016. As always, let me know if you have any questions that I did not address in the video. Thank you.